this is not my own stuff, but rather I was hoping that my students would come, my postdocs would come and talk, but they had other stuff to do. So I'm going to be speaking on their behalf. I'll be speaking in this talk, we'll be talking about the work from Mira Soni, who's a brilliant PhD student, and Ate Kirawati, who did her PhD and is now a lecturer in Indonesia and is still carrying out this research into different types of soy products. Shin just mentioned this effect of tempeh actually having a protective effect in the Indonesian elderly. And there's sort of being this age-dependent positive curvilinear effect of genistein. And so in this talk, I'm going to try to shed a little bit of light on why tofu potentially had a negative effect. So we mentioned the effects of pesticides, but I want to focus now on two other things, and that is thyroid function and the estrogenic effects of tofu. So when we look at tofu, that's soybean curd. You boil the tofu, you boil the soybean, and then you take the curd, and you get this sort of white, quite tasteless product, which you have to spice up with soy sauce and curries and what have you. Now, tempeh is made of fermented whole soybean, and because of the fermentation, it contains very high levels of readily bioavailable folate and cobalamin, both which are necessary for brain function. Now, when we found these differences, we had a whole range of hypotheses, and a whole group of people decided to look at this. PhD student in Indonesia, Aryani, looked at, for instance, the potential of formaldehyde, which was thought to often be added to tofu to keep it nice and fresh. Now, there were reports of this, and whereas that might be a really good idea, what formaldehyde does is it actually knocks holes into your brain. So this is not a very good idea at all. But when we looked at different tofu samples around Jakarta, we didn't find any formaldehyde in these. That was probably because the police had come down very hard on vendors who were doing that. So by the time we looked at it, that was no longer found. Some other people suggested, well, maybe it is because people who eat a lot of tofu actually are very poor, they can't afford meat, and they might not have any teeth, and so it's an artifact. We had two brilliant PhDs, Dr. Setiawan and Dr. Priyandini, who looked at loss of teeth and the association with dementia. And what they found in various populations was that having fewer than 10 teeth doubled your risk for dementia. And that was independent of a whole range of other factors. Now, that kind of indicates, we looked at sort of mediation of inflammatory factors, cytokines because of periodontitis, which can affect the brain. We looked at cardiovascular factors, perhaps having indirect effects. But it wasn't any of that. So we're thinking that that might have to do with the uptake of nutrients. Folate is available in green leafy vegetables, cobalamin in meats, and you need good teeth to chew these. So that might be one of the reasons of why loss of teeth, not just in Indonesia, but in the US, in Korea, in Holland, was found to have a doubling of risk. So fewer than 10 teeth doubles your risk for dementia. Not eating meat, well, Shushin just showed you, that also had an independent effect in China, and in fact, it was the reverse. So one of the things we were left with was that idea of pesticides, perhaps, or high tofu having a direct effect on thyroid dysfunction. Now, we did a lot of research in Cambridge looking at the sort of optimal levels of thyroxine, and that has quite a narrow therapeutic range. I'll show you that in a second, but this is data. These are not data from us, but thyroid peroxidase is an enzyme that is associated with the production of thyroxine. Now, these studies have shown across different species that soy can actually affect TPO. It inactivates that enzyme, and it lowers thyroxine. Now, thyroxine also, if you have subclinical thyroid disorder, and this is another study that was done in 2011, where they looked at people with subclinical hypothyroidism who were given soy, and these people had a 3 times higher risk of progressing to overt hypothyroidism. Why is that relevant? Well, in the particular area where we found the largest effects, there were endemic goiters. People had a diet very low in iodine, and in central Java and Borobudur, and they had endemic goiters. And so eating soy could exacerbate progression into this overt hypothyroid state. Now, this is data from Cambridge from the MRC CFAS study. And what we found in that study was that, yes, indeed, hypofunction of the thyroid is associated with low cognitive performance. This is well known, it's a secondary dementia. However, if we looked at the people who had so-called normal range thyroxine, we found that people with slightly elevated free thyroxine had a faster rate of cognitive decline and also low cognitive function at baseline. So that means that the therapeutic window, the therapeutic range for thyroxine is actually smaller than we think. And thyroxine, we need it for glucose metabolism in the brain, for optimal functioning. But if there's too much, it can create oxidative stress. And in fact, de Jong in the Honolulu Asian Aging study also found that it accelerated, that high normal thyroxine accelerated cognitive decline and was associated with hippocampal atrophy. Now, we tend to think of most substances to have positive linear effects. More is always better. But these data clearly indicate, as well as the soy data indicate, that there usually are curvilinear effects. And so what we can also see with that subclinical hyperthyroidism that we're talking about is that not only can it cause oxidative stress in the brain, knocking holes in the brain, affecting the hippocampus, but also disrupting the cholinergic system, which is important for learning, which has been implicated in dementia for a long time. So we were quite interested in this and revisited the Honolulu Asian Aging study. I was rather hoping that we could literally visit it, but of course there was no money for it, so we got the data instead. And what the Honolulu Asian Aging study did was they followed up over almost 3,000 Japanese American men, and they followed them up over time, assessing their tofu function. And Shin just showed you that data of also in this Asian population finding negative effects of high tofu consumption with poor cognitive function, faster cognitive decline, and also worse hippocampal atrophy. But they'd also assessed thyroxine and TSH. Now, these people had been assessed with the CASI, which consists of a number of subtests, so it's a total score you get out. And if you have a score that is lower than 74, which is calculated with all these different subscales, you are suggestive of having cognitive impairment / dementia. These men had also given fasting blood samples, and free thyroxine and TSH had been assessed at these various time points. Now, we were also interested in looking at sex steroids and various other covariates which could mediate or modify the association. So what we did is we looked at people who scored above and below this cognitive impairment score, and we tried to predict that using logistic regression. As suggested by most data, about 10% of this cohort had dementia at the time of testing, and that was associated again with a higher tofu consumption in these men, both in midlife and late life. The group who had cognitive impairment in general tended to be a bit older, they had fewer years of education, they had lower body mass and a higher incidence of stroke. Now, having lower body mass, that's a tricky one because we find in midlife that having a higher body mass index is associated with an increased risk. And again, here we see that change over the lifespan, with at an older age, people actually changing these risk factors and actually losing weight. We don't know exactly why that is the case. So what we tried to do first was we entered tofu, then we added in, then we just looked at thyroid hormones by themselves, then we added tofu to the thyroid hormones and put in the covariates. So that's mediation analysis to see if an entered variable explains the variance of the previous variable. Now, what we found was that tofu was associated with lower cognitive scores, as said, particularly in later life. And also, as previously found in the Honolulu Asian Aging Study, thyroxine was also associated with cognitive function, but TSH was not. Now, the majority in this cohort was actually euthyroid, so they didn't actually have, there weren't many people who had hypothyroidism in this cohort. Now, neither midlife or late life tofu consumption was associated with thyroid hormone, so there was not a mediation effect. So the effect that we found of tofu consumption was not explained by hyper or hypo function of the thyroid, but it should be noted that there were very few people with hypofunction of the thyroid, so we couldn't perhaps pick up that effect because most of these people had healthy goiters and normal levels of thyroxine. Now, in this final model, when we enter the covariates, you can see that there seems to be, as we found before in Cambridge, an optimal level of thyroxine. You can see that on the left. A negative association of late life tofu, positive associations, of course, of years of education. That's a well-known fact. Negative effects of age, but also, interestingly, a negative association of free estradiol and a positive association of free testosterone in these men, in these older men with cognitive function. Now, this is a well-known effect, and I wrote a review about it in case you're interested, in that in general, in older men and women, so we're talking over the age of 65, high levels of estradiol are associated with worse cognitive function. So this sort of supports these earlier findings. It was independent of socioeconomic factors. A lot of criticism towards the Honolulu Asian Aging Study was given because people said, well, you know, these are very poor workers, the Japanese Americans are not representative of other populations, but there was sufficient range, and these effects were not explained by poverty again, because that often comes in as a potential covariate. So what actually is going on? Well, we're now left with either some of the factors that Shin mentioned before, or its estrogenic effects. And there are estrogens, as I said, it's got a very tricky association with cognitive function. So in midlife, particularly for women going through a menopausal transition, elevating estrogen levels may be a good idea as long as neurons are healthy. And the older you get, the worse the effect of estrogens seem to be. So the estrogens seem to suddenly have a negative effect. Now, what is the issue? Well, phytoestrogens can bind to the estrogen receptor. They can bind both to the alpha and the beta receptor and have slightly higher affinity for the beta receptor. Now, this is a slide which I've often shown. It's a bit crappy, but there you go. I drew it myself on the computer. And what you can see here are the various potentially biological effects that estrogens can have in maintaining the aging brain. And as was said by Barrett Connor in 1999, its biological plausibility, the biological plausibility of estrogens to protect the aging brain is its strongest suit. So really, they should protect the aging brain. They can affect cerebral blood flow. Beautiful data by Pauline Maki has shown that. Stimulate glucose uptake in the neurons. They can stimulate the branching of dendrites within 24 hours because of co-localization with nerve growth factor. They can act as antioxidants themselves. They can protect against A-beta toxicity we talked about by its effect on splicing and the A-beta fragment. It can influence factors, many other factors like glutamate toxicity, and also because they can convert into catechol estrogens, can also act on neurotransmitter release. And there are many, many receptors throughout the brain. So really, estrogen should protect the aging brain. However, much to our surprise, in 2003, I was asked to come to the States to discuss this study. And this study is the Women's Health Initiative study. And it found a negative effect of estrogens on women's risk for dementia, on cognitive impairment. And these women, and that's interesting, that's what Shin already said, is these women were all older. They were over the age of 65. But at the time, we were baffled. We didn't understand how estrogens could increase the risk for cognitive impairment. And that risk was even doubled in the people taking estrogens. Now, these women were older, as said, and they were slightly at a higher risk for cardiovascular disease as well. They were slightly more obese, slightly higher risk for blood pressure. And I was sitting in my car driving home to Cambridge, and I heard this on the radio, and I still think it's one of the best things ever said, because after that study came out, many women stopped taking estrogens because all of a sudden there seemed to be a total paradigm shift, where before everybody was hoping estrogens could protect against dementia, and all of a sudden only negative results came out. So this is something, because I'd gone to Oxford to actually look at levels of sex steroids in Alzheimer's cases and controls. And I'd already found that the levels of estradiol were slightly elevated in the Alzheimer's cases. And I couldn't get it published because people said it can't be the case. This was in 1999, and people said that can't be the case. So I did 3 different assays, I did meta-analysis, and I kept on finding the same. If you used an assay of sufficient sensitivity, you would find slightly elevated estrogen levels in Alzheimer's cases. And then later, Christian Pike's group found the same in brains of women and men with high levels of estradiol in the cases as compared to controls. So all these studies had come out, and they were kind of trickling in, but they weren't getting into mainstream. So when this study came out, people started going back to these studies. And Professor Brinton Diaz from California, brilliant researcher, won several prizes for her work. What she showed was that what we alluded to earlier, that in healthy neurons, estrogens will maintain neuronal structure. However, as soon as there is pathology, if there are calcium channel issues or mitochondrial damage, estrogens will exacerbate that damage. They will make it much worse. Okay, so it's a little bit like, I liken it to my old Volvo. I've got a very old car, and if I throw super duper fuel in that and I start racing that car around, stuff just starts falling off. Whereas if you put the super duper fuel in a very nice car, a new car that you start driving in for very slowly, that super duper fuel will maintain your engine for much, much longer. So I think it's about that sort of effect. Now, we know that serum folate, low serum folate, is a risk factor for Alzheimer's disease, and that might be because of its associations with homocysteine. What we found in Oxford was that if women had sufficient serum folate and weren't deficient in serum folate, even if they had higher levels of estradiol, they did not run a risk of scoring below the cutoffs for dementia. So it might be that high serum folate protects against high levels of estradiol, possibly by acting on methylation. Now, surgical menopause, we earlier found if surgical menopause is induced before the age of 50, the risk for dementia is increased. So you seem to need a particular length of exposure to estrogens in the brain to maintain brain function in later life. The sooner you stop that, the higher your risk for acceleration of pathology, unless you treat. Now, this is data by Barbara Sherwin. There have been several small studies showing women who had not had a treatment and had undergone surgical menopause. And you can see in red, you can see that these women dropped in paragraph recall a staggering 10 words less recalled after surgical menopause had been induced. However, if these women were treated either with testosterone or estradiol, you could very nicely reverse that effect. If you then gave them placebo, that effect went back down again, and if you gave them treatment, they reversed back again to their normal functioning. So giving treatment up to the age of menopause seems to protect, and there have been several studies now. If you're interested in that, we wrote a review for, I can't remember where, but I can find it for you and send it to you if you're interested. Now, phytoestrogens have very similar effect, and Shin already talked about this, to as estrogens, and this is again data from Robbie Brinton's lab, showing that if you induce hippocampal damage through glutamate, but you give estradiol at the same time, you can reduce that damage, and that has the same effect as genistein, the most potent isoflavone, has. So Attic did some work with rats, and she oophorectomized them to simulate what happens in women, and she trained them to do maze tests. So these are memory tests, visuospatial memory tests for rats. And we first picked sort of middle-aged rats. They were about a year old, and they were oophorectomized, and then what happened was the following. So you can see the baseline, and you can see what happened. There was a drop on the maze test at baseline 2 after they recovered from the oophorectomy. But if they were given Tempe, you can see that their memory functions much improved over that of baseline. And that improvement was maintained over time when these rats obtained an older age. You can see sort of similar but slight delay for estradiol and for tofu, but in estradiol you can also see that the effects start reversing as the female rats get older. Casein, a protein, was used as a control, and you can see that there was a slight learning effect, but it certainly was a good control for the Tempe, and it was highly significant. Now, what was really striking was beta amyloid, and we talked about this a lot as a marker for Alzheimer's. And what you can see was the rats, first of all, that the rats who underwent the oophorectomy had a massive increase in beta amyloid. And this is similar to data from Almeida with men, showing that after castration, markers for beta amyloid tend to go up massively. But if you gave these rats Tempe, that level of beta amyloid was below that of baseline. And that seemed to be maintained for some time. Whereas for tahu or tofu and estradiol, the effect just went back to baseline. Now, these time-limited effects Shin talked about, and these were earlier data from London, showing that in recently menopausal women treated for about 3 months, there were positive effects of phytoestrogen treatment for up to 3 months. However, in this other study by Crit Silverstein, which had a larger proportion of women past the age of menopause, there were only very few positive effects found. And this was 6 months after baseline. And what Shin alluded to is that these effects of estrogens, and we've done some Cochrane analysis to show that, they seem to be most potent the first 3 months and then seem to reverse. However, with Tempe, and you could see that simulated in the rats, that effect seemed to be maintained for longer, perhaps because of the addition of folate. So one of the things we then did, and these are new data from Attic, she then did it in older rats with the equivalent of 60 years old. And what she now found, so these rats were oophorectomized because rats don't have menopause, you need to oophorectomize that, is what she then found was, and this is a slightly complicated slide, you can see that Tempe maintained cognitive function in the females, so that's the light blue line on the top after oophorectomy, but that the casein controls, you can see, had a decrease in functioning. Most importantly for tofu, after an initial positive effect, the effect then decreased. So this simulates what we saw in humans. So for older humans and rats, the effects of tempeh are not positive over a longer period of time. But worse, with tofu, the rats in this quite high dose of tofu started developing cysts or tumors. We're not entirely sure what they were, but they got massive cysts here. And I suspect it might be the goiter that has actually started to grow. So, giving tempeh may maintain cognitive function longer in middle-aged women. It seemed to do it in rats, so it could be an alternative treatment. Tempeh doesn't show this sort of drastic reversal of effects after 3 months as estradiol and tofu did. There was some data, some pilot data that seemed to suggest that even in older women as well with Alzheimer's disease, but we'll present them later when we've got more data. But giving such high dosages is not without risk. Certainly of tofu, we found these cysts, and in fact, most of the male rats packed in. They didn't like the tofu at all. And with tempeh, we didn't see any mortality, but we did find one cyst in one of the rats. So we need to look at the dose, as Shin already said. So, in sum, our Indonesian and Chinese data show the same as the Japanese-American data of White and of Rice. She also looked at Japanese-Americans, and that high tofu consumption was associated with worse memory function and a higher risk of dementia. That's very similar to estrogenic effects in women. And interestingly enough, Kame found that if women were taking hormones with estrogens at the time and had tofu, that effect was even worse. Now, we found in recently menopausal women, middle-aged menopausal women and men, curvilinear effects. So in midlife, these effects could still be positive. And well, we need to find out what the mechanism is. Is it because tempeh contains folate or B12? As Shin alluded to, turmeric in curries are also neuroprotective. And the way people make tempeh in Indonesia is they coat it in turmeric before they fry it. So what the exact mechanism is there is not entirely clear. It might not be the tempeh at all. It might be the turmeric, but then again, when we gave it to the rats, we had freeze-dried tempeh, so it was tempeh only. We freeze-dried the tempeh and put it into powders to feed it to the rats. So that's just that tempeh in its own right has got very potent effects as well. These are data I hope will be presented next year in London by Professor Brinton Diaz, and she discovered a novel phytoestrogen, and it acts more selectively on the estrogen beta receptor, so there aren't any uterine effects, no effects on the breasts. She's found in her cell culture studies that it regulates mitochondrial function and energy production, and that in animals after oophorectomy, the decreased activity in these bioenergetic enzymes seems to be restored with this particular product. Now, importantly also, it reduces lipid peroxidation, so there's less oxidative stress, and improves cholesterol profiles, and also affects beta amyloid production and clearance. Now, she's done a study in women with Alzheimer's disease to test this product, and so we're waiting for these results, and hopefully she'll present them next year in London. I'd like to thank the team in Indonesia. You can see in Indonesia you get much more bang for your buck. You can employ many more people, and this is our entire team there. It only cost us £30,000. People worked incredibly hard. Within 6 months, they had all the data together. And so we have to thank Professor Tribudi for doing that, and of course the people from the Shanghai Mental Health Center. Xu Xin very kindly worked with Professor Xiao Shifu to do the data collection there. We're very grateful to the University of Bogor for their animal facilities, the University of Oxford, my mentor, Professor David Smith, also, of course, the grants that we got to do this work from the MRC, the NDA, and the British Council, and the Alzheimer's Research Trust, and of course for you for listening. Do you have any questions about this? Yeah? Yeah, it's interesting because tofu, a lot of people, it's interesting, if you looked at estrogens before the negative results came out, everybody ignored the effects on breast cancer. And in reality, the increased risk is 1 per 1,000 women, so it's not per year. So it's not a big risk, but it's still an increased risk, a slight elevation of risk. Mortality in these women is down. And the actual Women's Health Initiative data, what they showed was, it's data from Jacques Rousseau, and if you give women right after the menopause estrogens, even if you give estrogens by themselves, women seem to be protected against breast cancer. But you can only treat up to 5 to 7 years because then the risk starts increasing. So again, I think if there's pathology present, which you are of increased risk as you age, estrogens seem to accelerate that. So it all depends a little bit on the state. Now for tofu, again, that picture is very blurred because a lot of people say because it acts much more selectively on the estrogen beta receptor. And so people are saying, well, that risk for cancers is lower. In fact, it's reduced because phytoestrogens act as a partial agonist and antagonist. So if estrogen levels are high, they'll act as an antagonist because they sit on the receptor and they don't allow estrogens to exert their potent effects. Whereas if estrogen levels are low, they act as agonists by upping this sort of estrogenic activity, but they only have half of the activity. So that picture is a little bit blurred. I have not personally come across studies, but again, I haven't looked at that in great detail, suggesting increased risk of breast cancer with high tofu consumption. So I don't know that. Chin, have you come across that? No, I haven't. No, not either. So, but again, I think the cysts that we found in the rats are probably more to do with the thyroid gland. I think that was because you could see that TPO is deactivated by such high. So I think the goiter is just trying to produce more thyroxine. But we don't know what it is yet. We're looking at to see what is actually causing these cysts. Obviously, we don't want to have our patients walk around with a massive cyst under their neck. So, yeah. Yes? Yeah, that's a really good question. So I was looking at this data and I was talking to some of the medics in Indonesia and they said, of course, the effect of tempeh is so strong in Borobudur because they have a black soybean. And this black soybean is supposed to have very strong medicinal properties, far stronger than any of this genetically modified business. And it also grows in quite harsh conditions. So it's much drier, for instance, in these particular areas. And its antioxidant properties are probably very, very, very good. One of the problems is, though, that because of the soy lobby, Indonesians are increasingly forced to import soy, genetically modified soy, from all over the place, rather than to be able to grow their own soy. So there's a decreased production of local soy, including this fantastic black soybean, and an import of the genetically modified product, which is probably it's got very different biochemical properties. But again, we're looking at the different compounds. Tempeh, interestingly enough, was shown from that black soybean was shown to have really high levels of estrogens, or the genistein, rather, sorry, of the phytoestrogens. So, yeah, but that must be counteracted by the folate, cobalamin, and possibly the other nutrients in it, because it contains an awful lot of good stuff because of the fermentation. If you want to eat it, I'm sure you all do, let me tell you that it tastes a little bit like cardboard. So I love it, but it's a bit of an acquired taste. So what you want to do is you want to add a lot of garlic, onions, and peanut butter and soy sauce. And then it's really nice with vegetables. Do not attempt to eat this by itself. Okay, thank you very much. So that's for tempeh. I'll now go on to the other talk, which I'm giving for Veronica van der Wart. Now, Veronica did a lot of really brilliant work, which was funded by an NDA project, which was called SUSIT. And this was about getting older people to engage with the internet. And so this talk is about lifestyle interventions and whether we should use the internet and whether internet use in itself can protect against dementia. Now, internet use in itself has been found to be associated with a reduced risk of cognitive decline, but of course cause and effect here is very difficult to discern. I'll show you those data in a second. But, on the other hand, internet use could also offer support, and increasingly more elderly, whereas a couple of years ago it was only 25% of elderly using the internet. As we've heard earlier, that number has significantly increased, with in some parts now 75% of people, of older people over 65 using the internet. What we're interested in when we're looking at these sorts of functions, and these ladies are the same age, is that enormous variation in functional and physiological ability with age. And that difference exists between people, but also within people. So different organs within different people age at different rates. And so where, for instance, nerve conducting felicity doesn't change that much with age per se, female fertility, as we just talked about, usually stops around the age of 50 and then could have important knock-on effects. So how you age and whether Alzheimer's is a form of accelerated aging is under debate. Now, Bill Evans, who I worked with in Arkansas, found that if there is no morbidity, which is very rare in older people, there isn't actually that much change over time. So, for instance, heart rate doesn't show a very significant change if you don't have any morbidity. Your total lung capacity, your renal blood flow shows a slight decrease. But in general, if there is no morbidity, the organs and organ function stays relatively intact. But most elderly will have morbidity. So if you're trying to exclude for morbidity, you will find a very different group, a sort of a superhuman. The deficits in sensory systems, deafness, for instance, we talked about, blindness or cataracts will affect how you process information. We had some lovely talks about that yesterday, trying this out, with these various techniques, trying to get younger people to understand what it's like to view the world and hear the world as older people do. We also found that a lot of elderly in Oxford had undetected urinary tract infection or upper respiratory tract infections. One of the issues with older people is that about 20% of the elderly do not show an elevation in temperature with an infection. And they'll present with delirium, they're drowsy, they're not quite there. And unless you're actually checking the bloods, you're not finding out that this is an underlying infection. And it is that strong that in Oxford we could see that people had a real dip on the MMSE, which once the infection was treated was completely reversed. So it's worthwhile checking the bloods if an older person presents with drowsiness and delirium. A lot of the elderly will have strokes and heart disease, organ disease, systemic disease, and of course there are the endocrine changes we talked about. We talked about the thyroid function, we talked about the sex steroid change, which declines with age in general. But also diabetes, and diabetes, currently Alzheimer's disease is called diabetes type 3 because of its similarities. And in fact, in the brain, insulin is produced, there are specific insulin producing cells, and they're affected in Alzheimer's disease. So the brain has its own homeostatic mechanism to maintain glucose levels within a very small margin, because high levels of glucose are incredibly toxic to the neurons. So all of this morbidity can affect how we function, how we interact with ICT, and how active we are. So if we're looking at dementia, what we now know from all these longitudinal studies is something that Shin mentioned before, which is what is good for your heart is good for your brain, and vice versa. And most people by now, because of very active public health campaigns, know that being obese in midlife, having high blood pressure in midlife, having high total cholesterol, having diabetes, each of these individual factors in midlife will double your risk for dementia. But they act cumulatively. So if you smoke and you have diabetes, you've got an increased risk of a factor 4. If you have high blood pressure, which you might not be aware of, high cholesterol, and you smoke, you can have an increased risk of a factor 6. So most of this is modifiable. We can do stuff to improve our blood pressure status. We can improve our cholesterol, our risk for diabetes through diet and exercise and not smoking. But there are things, of course, that are a little bit more difficult to change, such as having education. Now, education is an interesting point because the Aberdeen studies and British birth cohort studies all found that having a low IQ at the age of around 11 or little education, little obtained education, increased your risk for dementia substantially. And this sort of suggests that there are some early life factors, that there is some cognitive reserve that we're building up. And the way that works, according to Margaret Aziri's work from Oxford, is that you have a particular cognitive reserve, and once there is an amount of pathology, so that's strokes, plaques, the Lewy bodies we heard about earlier, that cognitive reserve drops under a cutoff, and then symptoms become apparent. However, if you have a great amount of cognitive reserve, you can override that degree of pathology for a longer time. And so the idea would be that you reach, if you have high levels of education, you reach that threshold at a much later state, but when you reach it, your decline is going to be much faster. And a couple of studies have shown that. So from onset of dementia in these high educated people to death is about 2 years versus 6 to 12 years in people with lower levels of education. And these are Swedish data showing that. Now, the question is, can we, through lifestyles, which would include diet, exercise, maybe even education in older age, still increase that threshold so we develop dementia at a later stage? Now, what can we do? Well, we can stop smoking. I told you before about the teeth, how important it is to maintain good dental health. Mediterranean diet now. We just wrote a white paper with Victor Henderson showing that consumption of the Mediterranean diet, so that's lots of nuts, fatty fish, olive oil, can all reduce your risk for dementia. Eating beans, lentils. Lentils contain a lot of folate, but they also contain fiber, which will reduce your cholesterol. Lots of vegetables, fruits, whole grains, and perhaps dairy products, little red meat, could all reduce the risk for dementia. But again, you have to be a little bit careful with this because, of course, fatty fish will also contain heavy metals. They're predominantly stored in fat, and so you don't want to eat that more than 3 times a week, perhaps. The same goes for the green vegetables. In Indonesia, you might actually be running a risk because of pesticides. But normally, for instance, spinach and kale, broccoli, they can contain nitrate, which can increase your risk for stomach cancer. So again, you want to eat this in moderation. You don't want to be eating it all the time. And variation, as my grandmother said, is probably the key. You should exercise. Now, everybody's getting a bit sick and tired of hearing this, and these guidelines are variable. According to British guidelines, you need to exercise 150 minutes a week, moderately, or 75 minutes vigorously. So that means, unfortunately, sweating, increasing your heart rate, improving your lung function. So you can't just be sitting there with the Wii Fit, you know, doing a bit of tennis. You really have to be out there and sweating and breathing heavily, etc. Now, we were interested in what resistance exercise in its own right could do, because currently within the British guidelines, they added as a sort of almost like a bit of an afterthought. It's like, oh yes, and do some resistance exercise as well. Now, resistance exercise, so improving your muscle strength, possibly, according to some studies, in itself could improve memory function. Now, this, of course, is much easier to do, because you can sit there watching EastEnders and just doing a bit of resistance exercise with some encyclopedias or some bags of beans or whatever you want to do. So that's much easier to do. In general, exercise, as I said before, it can lower blood pressure. I got a dog. Don't ask me how or why. It was because a cat died and there was a promise. Anyway, so I had to get a dog, and I had to start walking that dog. And I already had pretty good blood pressure, but because of this stupid dog, my blood pressure dropped even further. I had to walk it for an hour because it was a nervous terrier and otherwise would eat the couch. So I had to walk it every day for an hour. Within 3 months, my blood pressure was down. My LDL cholesterol wasn't even found anymore. My HDL was all the way up. I lost all the fat I had. So get a dog. Not a terrier because they're horrible, but something nice and that doesn't eat cats, for instance. So, but it can also directly improve the blood flow to the brain. It improves vascular function. It improves your immune system. So initially you have a dip often if you exercise very, very vigorously, but it then seems to strengthen your immune system afterwards. It can decrease toxicity of the beta amyloid, increase neurotransmitter synthesis, and Van Praag, his Dutch professor, also found that even in older rats, you can see improved neurogenesis, or actually the sprouting in the brain happening. So that's fantastic. We did a little study for the BBC, in which we had all the people either cycle for 20 minutes or do some ballroom dancing or Sudoku. And what we found was that the people who did acute cycling for 20 minutes had improved executive functions, measured by this troop, and improved memory functions, episodic memory functions. The people who did the ballroom dancing also showed some improvement, but it was less. And the people who did Sudoku for 20 minutes got worse. Now, why was that? I think they were just bored. I mean, personally, I'm very bored with Sudoku. I can't do it. I'm too stupid for it, and I don't understand it. So, I mean, I could completely see where they were coming from. But what I'm trying to say is that not all cognitive stimulatory activities will improve function. In fact, it can make it worse if it bores you. But the people on the bike and the people who were dancing had a lot of fun. So if we're doing exercise with all the people, you have to make it enjoyable. So Angela was another really brilliant PhD student we had, and she did a great review. If you're interested in, I can send it to you. We do a lot of review writing. And what she found was that exercise doesn't just affect everything. It seems to affect simple episodic memory tasks most, in sharp contrast to what most people think. It seems to affect particularly memory. Not all types of exercise are good. Yoga we use as a control condition because it doesn't seem to improve cognitive function. I'm not against yoga. I keep on getting hate mail from vegans who do yoga and say, you're a meat eater, you hate tofu, you hate yoga. And it's like, no, it's not true. I like both of them. I really like yoga, I like tofu, but it just doesn't improve memory functions in the older people. So it doesn't, but what yoga does do is it helps maintain balance and could protect against falls, and falls risk is increased with dementia, and it also makes dementia worse. So yoga exercises are a good idea, but they don't improve memory by itself. In the white paper that we wrote with Victor Henderson, Tai Chi also, in the meta-analysis, seemed to improve memory functions. So Tai Chi is not an aerobic exercise, it's not yoga, but it's very controlled, sort of slow movements. What we also found in this meta-analysis was that women benefited more than men from exercise, which is really interesting. I don't quite know how, I'll show you that in a second. And in particular, aerobic exercise seemed to be most effective. However, in that review, we also found, as I said, that there was some suggestion that just doing resistance exercise, strength training by itself could improve memory. So that's what we did. We used resistance bands, and we used yoga as a control, and we had cognitive testing, and these are some of the tests that Professor Fisher mentioned earlier. We had these tests, we had computerized tests, we had paper and pencil tests, and this is the sort of normal run-of-the-mill, measuring executive function, memory, measuring visuospatial functions, etc. And what we found was that in particular, and these are effects of 12 weeks of training for 20 to 30 minutes 3 times a week. And what we found after 6 months, so that is the first time point, number 2, After 6 weeks, strength training significantly improved memory on 2 memory tests, and that was maintained after 12 weeks as compared to yoga stretch. So they received the same amount of yoga exercises, and we found that that effect was highly significant. Now, these were small groups, and we didn't see it on more complex executive functions or global cognition. We found that specifically on memory. There have been other people finding effects on global function in people with dementia, but it's a very small group, again, mainly women, and showing that if you did a mixed stretching, so you added the sort of yoga condition to the strength versus a control condition, you could see that the mini-mental state examination significantly improved over 6 months and 12 months. So these are people with dementia. However, many studies have not shown these positive effects of exercise in people with or without dementia. And the latest Cochrane analysis concludes, in sharp contrast to the earlier Cochrane analysis, that the effects are no longer significant. However, that meta-analysis is affected by a lot of heterogeneity. So there is large variance between the studies, and that means they can't really be compared in one meta-analysis. And if you look at the plots, you can actually see that the majority of the studies find positive effects of exercise. However, there is 1 or 2 with a high weight which pull the effect away. So I take that with a bit of a grain of salt. I take Cochrane with a grain of salt anyway. Am I being taped? Oh, hi Cochrane. I do love you, not. Okay, so exercise treatment can improve cognition in elderly already after 6 weeks, but you can see longer term effects as well. You need to have the correct intervention, and I think strength training is definitely very promising, but also walking, as some other studies have done, is something we're trying out now. Strongest effect seems to be memory, but why these effects are so strong in women needs to be explored. For instance, we're looking with a study in Portugal, we're looking at changes in the sex steroids. It might be that. Maybe the testosterone goes up after strength training. We're looking at psychological effects like resilience. The women are more likely to adhere to the interventions as well. Maybe it is a change in their mood or the whole social environment women are more susceptible to. So we're trying to tease apart why women are so much more, there's usually also more older women in these studies than men, so it could just be an effect size. So what about mental activity? Well, mental activity is also associated with a lower dementia risk. And there's been the famous NUN study, which was mentioned before, where they found that women who had a lot of hobbies and also who in their diaries over 22 years, from 22 years onwards, had a high ID density, so had a big vocabulary and lots of expressed ideas, had a lower risk of dementia. So this might indicate that cognitive reserve that we talked about earlier, having more connections between cells, making them less vulnerable. And the next speaker is going to be talking about this when she talks about how art can affect this cognitive reserve. In Indonesia, we also found that people who were cognitively impaired were much less likely to read or write letters or watch telly or go to social gatherings. And again, these effects of social isolation are very well described in people with dementia. Now, we found that the people who did read, write, and watch television had much better memories. And of course, as we said before, memory is one of the first functions to decline in dementia. And from this, you could suggest that maybe people should do reading and writing exercises. And indeed, Kawashima in Japan has done that. He started a learning therapy, and he's done some small studies in Japan and in America showing that if you give people with quite severe dementia reading and writing exercises, arithmetic exercises, the improvement on the MMSE is dramatic. So that is interesting stuff, but the studies are small and they need to be replicated. These are other observational studies from my collaborators from the PRIDE study. This is a large £4.5 million grant over 5 years where we're looking at these lifestyle interventions, trying to give them to people over the internet. And what they found also was that digital literacy and culture, leisure activities, vigorous physical activity from the ELSA study, which is a large longitudinal study, was associated with less risk for dementia, with better cognitive function, and particularly among poorer people. So it seemed to protect people against low socioeconomic status. Why is this important? Well, low socioeconomic status across the lifespan is associated with an increased risk. You grow up often in polluted areas, there is noise, there is stress, less adequate diets, your parents don't take you on winter holidays, so you don't get any vitamin D. There's none of this cognitive stimulating stuff going on, like expensive piano lessons and learning different languages. And so having a low socioeconomic status in its own right can significantly increase your risk for dementia. However, education, and this study shows that even if you're older and you educate yourself through digital literacy, you can overcome that negative effect of poverty on brain function. These are data from Brazil, where they also found, again using observational studies, that people who did a lot of emailing had functional independence. I'm sure that will protect all of us. And what they also found, and that is very important, is that, and this is problematic for observational studies, is that people seem to do a lot of stuff. So if you email, if you use the internet, you're also more likely to engage in vigorous exercise, you're also more likely to eat fruit and vegetables, you're less likely to smoke. So the problem with these lifestyle changes is that you see, and we can see it in Indonesia as well, you either seem to do it all, like you're good, you don't smoke, you eat well, you exercise, versus you don't do any of that at all. So there seem to be almost two groups. So it's very difficult to entangle what the protective effects actually are in these observational studies, because people, once they do one thing, they usually do another as well. They're more likely to read and write as well. So the other problem with these observational studies is cause and effect, because you don't know whether people aren't engaging because they can't. We can see social isolation happening quite early on because people feel embarrassed. They have problems with vocabulary and they no longer feel capable of engaging with people. Now, however, there is a bunch of randomized controlled trials also showing positive effects. And one of these is cognitive stimulation therapy. I mentioned learning therapy by Kawashima. But at UCL, Professor Martin Orrell and Amy Spector developed this cognitive stimulation therapy, and it's very nice. It uses, you can do it in groups, or you can do it, for instance, with family members, where, for instance, the son will ask his dad, he will give him a £5 note, and he'll say, oh, do you know what you could buy for £5 now? And, people often have issues with that, and, if you see people struggling, you then say, well, how about when you were young, Dad? What could you do with £5? And people have to go back, so it's reminiscent therapy. So you're getting communication, which is nice, because people will talk about the salary they had. But you're also asking them to do mental arithmetic. And so you're training people in a very playful way, using communication and using games to engage people and stimulate people. And this is available online. You can look at cstdementia.com. You can get it for £16. It's a bargain, the booklet with the different exercises, and I can definitely recommend it. In various studies, it was shown to improve global cognitive functioning as well. So why would this work? Well, this is a slide I got from the internet. And what you can see is that these are older rats, and it's based on a very early study in '64 by Diamond. And what they found was that if you put older rats in an enriched environment, so you put lots of play stuff in it, you can see active dendritic sprouting happening. And this was very important at the time, because previously we thought that older brains were not very flexible. there would only be loss and not much gain. But these studies showed that older rats, when exposed to stimulating environments, would have dendritic sprouting. However, as you can see in this animation, is that when a rat is exposed to stimulation, it will also run around a lot. So it also engages in physical activity. And the question is, you know, what is it, chicken or egg? As I said before, the whole problem is people who engage in one usually will also engage in the other. They'll engage in physical and also in cognitive work. So this study by Barnes found these were older adults with cognitive complaints, and they were given 12 weeks, 60 minutes over 3 days per week, physical exercises. So they were either given aerobic exercises or with strength exercises or stretch exercises as a control, or they were given computer games, or that was added to it, or educational DVDs as a control. And what they found was that all of these conditions, whether they were done by themselves or in combination, improved cognitive function. So there wasn't a difference between one or the other, but it was the amount of activity people engaged in. So the message there is quite nice, actually, because you can say, look, and that's what we're doing in Pride, we're giving people the opportunity and saying, okay, from an evidence-based, we know that this stuff works, like resistance exercise works, but if you don't like it, you can also walk, or you could do puzzles, or you could do reading, or your music therapy, or art therapy. It's the amount of activity that seems to matter. And a recent study published in The Lancet by Maria Chiavi-Pialto was done phenomenal work in dementia, treated people also again with a combination of dietary advice, exercise, again doing strength exercise, anaerobic training, brain training exercises, and also medical management of these vascular risk factors, so bringing down cholesterol, treating high blood pressure, etc. Whereas the control group only received health advice. And I found after 2 years quite a staggering improvement in executive function of 83% and of processing speed of 150% improved information processing speeds. So if you want to do this over the internet, and I was going to talk to you a little bit about, I'm just going to check, 1:45. I guess I'm running over time, so am I okay? Cool. Okay, so if you want to do this over the internet, what do you need to know about how older people work with information processing and how people can engage with the internet? Because, as we talked about earlier, Professor Fisher gave a lovely overview of these functions that are impaired in dementia. We need to take that into account if we're going to try to do an intervention over the internet, which of course is very cost effective, is always available, people can engage with it when they want, etc. Now, in normal aging, what we see is that complex speeded tests, so if people have to inhibit functions, and Professor Fisher talked about this before, if they have to inhibit functions, if they have to do sequencing, or if they have to divide attention, the time taken to do these tasks take longer. But also their learning capacity, so episodic memory, is also often a little bit reduced. Again, importantly, also again pointed out by Professor Fisher, the variability in functioning increases dramatically. So you have people who are better than young people. You have people who are very much worse, like people with dementia. And this is one of these inhibitory tests where you have to read the color of the name of the color printed, not the color itself. So the color name, but not the actual color. And we are, so you have to mention the color that it's printed in, not the actual name of the color. And that is very difficult because reading in literate people is an automatic response, so you have to inhibit it. So that would be gray, brown, yellow, blue, yellow, whatever that color is, orange. And this is very hard to do, and with age, older people slow down on this task considerably. Now that's for normal aging. What about dementia? Well, the dementia diagnosis primarily, initially, is usually for most of the dementias one of memory dysfunction. However, as we've heard over the last couple of days, with different types of dementia like Lewy bodies, it usually has a different presentation as to the frontotemporals, but frontotemporal dementia is relatively rare. It's about 5% of the cases, Lewy bodies about 20, vascular, depending on the data you look at, maybe 20, and then the rest is Alzheimer's disease or mixed. Now, these tests that we're using, as Professor Fisher also said, is there are global tests, but these don't pick up the very subtle variants, and what you need to do as a neuropsychologist is to look at a profile of functioning. And this is a test we like to use. I didn't initially like to use it, but I was paid by Bristol Myers Squibb, and they said, do this test for us. And as a neuropsychologist, I thought, well, why would I do that? Because that is only 12 words, it's very simple. And they wanted me to do it because they wanted to see if it could distinguish between vascular dementia, Alzheimer's, controls, and MCIs. And it could. Now, what that test does is you read the words out loud with about a second in between, and you read it at the same tone of voice. And as you can see, so it would be lion, emerald, horse, tent, sapphire, hotel, etc. So read it out loud, and as you can see, as most controls can see after the first run, is that, well, what can you see? Actually, let's just do a test. Yeah, there are categories. Well done. You do not have dementia. You're the only one. Sorry, the rest of you needs to go for extensive testing. So there are categories here of animals, of human shelter, and semi-precious stones. Now, the good thing about it is that the animals are relatively early acquired, have high imagery, but they're not very frequent in language. Whereas the other two categories are late acquired and are very infrequent in language. And this determines how good recall is going to be. So a control would use the categories. So you read it once, and as Professor Fisher said, with most of these trials, you will do that repeatedly, and you do that with this one as well. So you read it the second time. Now the control knows that they have to use the categories to remember the words. But people with Alzheimer's can't do that because they haven't realized that there are actual categories, and then they can't use it to link the information in. And what we can see in that test, if you look at the total over 3 trials, there's a very clear distinction in green between the Alzheimer's cases and the controls. And it does not have a ceiling effect. And not only could we use it in Oxford, but we could use the same cutoffs for that test in Indonesia and in Shanghai. And Shin has just published a lovely paper about that. But as Professor Fisher said, we need to look at profiles. So we do, even in screening, we need to do a bunch of tests to see where the issues arise. And I will talk about these different tests in a minute. What we found, for instance, in Oxford is that in very early Alzheimer's, about 1/3 of the people will only do badly on this Hopkins verbal learning test, that memory test. 1/3 will do badly on a visuospatial test, and 1/3 will do badly on both. And that might have to do with where in the hippocampus the initial damage starts. This is a test that is developed in Cambridge in the CANTAB, and it's called the Paired Associate Learning Test. And the way that that test works is you will see a symbol now in the middle, and that's supposed to be a non-verbal symbol. Now, I think that is a razor blade, but it's supposed to be non-verbal. Then the patient is asked to identify where that symbol, so using touchscreen, appears on the screen, and it's down there. Now, people with Alzheimer's, if they don't get it the first time, they can try it again. And people with Alzheimer's seem to need about 6 tries before they can identify where that test is. And using this test for early detection seems to be very good. However, we don't use it because it's A, expensive, B, we need a computer screen, and C, we've got cheaper tests to do in the middle of nowhere. So we don't use it, but it's a good test, and it's used a lot, and it is very sensitive to early detection. But we prefer to usually use paper and pencil tests. We find them easier to take into the jungle or the desert or wherever we're testing. The way we test sensitivity and specificity is by using receiver operating curves. Now that's a statistical test. If you are afraid of statistics, start with receiver operating curves because it's a lot of fun, it's very easy to do, and it's very gratifying. So how does that work? Well, you're plotting sensitivity versus specificity. And here is sensitivity and specificity for a bunch of tests we looked at in Oxford. And we were interested in specificity, the ability to say that a control is not a case. Yeah? So not so much picking up cases, because that's relatively easy to do. It's far more difficult in a questionable control. And what we found was that the Hopkins verbal learning test was very good at this, but also category fluency and Boston naming tests, and these are language tests, and also the clocks. And I'll show you the Boston naming test here. So we talked about this before, how naming tests are affected in dementia, and people really have issues in naming this. Now I do too, because I'm not Dutch. I am Dutch, sorry, I don't even know what I am anymore. So I am Dutch, but I don't know what this is called. And there's other stuff like tassels, and I don't even know what that is. Now I took this test to Indonesia, and I showed them one of the items, which is a tutu. And I said to people, what's this called? And people had no idea. So we don't use this test either, but in a normal, well, not normal, but in an English population, it's a good test to use. The category fluency we do use, and this is quite similar in some ways to this Hopkins verbal learning test, in that it combines executive function, language function, and memory function. So you ask people to name as many animals as you can within a minute. And controls will often start using categories of animals, like farm animals, zoo animals, sea animals, and you can have a clear cutoff there for the Alzheimer's cases and controls. And this is the clocks, and you ask people to draw a clock, and that test tests both executive and visuospatial functions, and a little bit of memory as well. Now, very important, so what we see here is that very clearly different aspects of memory are quite severely affected quite early on, including language functions. So if you're asking people to name stuff while you're doing interventions over the internet or trying to memorize stuff to go on to the next page, you're running into trouble. But this was very important. This is work we did in Oxford, where we looked at visual search, and we found that with different gradations of difficulty, visual search is really significantly affected in mild cognitive impairment in early AD. And this is how a control responds to stimuli which appear across the street. So these stimuli increase in probability to form a figure, and as soon as somebody sees that figure anywhere on the visual screen, they have to press a button. And you can see here that the highest response speeds are in the center. Yeah, so people always respond fastest to the center and slower to the periphery. So the color coding is slow is towards the tan, and the faster is towards the purple. But this is the average profile for the people with mild cognitive impairment, and you can see that that central field advantage, so this is for the controls, that's for the cases, is lost. So the whole reaction times go down, not just in the periphery, but also particularly in the center. And that is problematic. So if you are giving information, you need to leave that information on the screen for long enough, and you don't want to have any distracting information in the periphery. And a lot of websites will have stuff flashing, and so you need to have a good font size. You need to make sure that it's there for a long enough time, and you may need to guide people to where they need to look. One of the other studies we did, and we were hoping that this could work as diagnostic, but the receiver operating curves weren't sufficient for it, but it was interesting. And we looked at visual scanning of faces. Now, everybody who's worked with dementia, and I assume it's most of you, will have noticed that as soon as somebody comes in, you can almost tell. You know that somebody's got dementia. And I was always wondering, what is it about it that makes people not know, that makes people realize that somebody's got dementia? And I realized it was that. Normally, when you meet a new person, they scan your face. So they spend a lot of time on your nose, your mouth, a little bit, and most of the time on your eyes to memorize what you look like. But people with dementia don't do that. They have a very random sort of scanning, and they don't actually spend a lot of time doing that. And subconsciously, you're picking that up. which is another reason why people can't remember who you are when you meet them the next time around, because they're not scanning you effectively. Whether that's an emotional phase, you can see here in the age-matched controls, when somebody is emotional, people spend even more time scanning that phase. But the Alzheimer's cases don't do that at all. Now, the reason we didn't use it as a diagnostic was that it didn't work very well when people wore glasses or when they had very dark pupils, but we're hoping that technology will catch up. And it might be something that you could use in a GP practice for people just to see how they're scanning the doctor's face. That's something we were hoping. However, all of that sort of change, the normal slowing with age, the relative problems in learning new information, a lot of new information, especially with distraction, which is exacerbated in dementia. And, there's all these other issues as well, visuospatial effects that we found. Location learning, word finding, visual search, scanning, face recognition. So you have to have that inform your web design. And we already work a lot with designers, looking at, for instance, using symbols, avoiding distracting information. One of the other problems in dementia is often that the ability to distinguish on the blue-purple contrast is decreased, and there's a blurring and a relative decrease in contrast. And so what you want to do is work, for instance, reds versus whites are still picked up very well, sharp blacks versus whites, but you don't want to use the blue versus whites because there are issues in making that distinction. So when you're designing, you've got to take that in the back of your mind. You've got to present the information slowly, and you don't want to be questioning people, to use their memory if they have to navigate the site. So no passwords, no complicated if-then stuff. And what we did in Loughborough, what Veronica did, is she looked at people with memory and other issues. They were vulnerable people. They were in a support group. And we had a bunch of questionnaires and our tests. And what Veronica found, and I'm going through this relatively quickly, my apologies, but we're running out of time, is that quite a number of people, about half of these people, even though they were very vulnerable, they were low socioeconomic status, they had frailty, cognitive impairments, half of them, about 40% of them, used a computer, the majority in the library. Now, this is important because in the UK, a lot of libraries are being shut down, and these are actually very important provisions for elderly, not just because it gets them out of the house, but also to interact with other people. So we need to lobby to keep these intact. Most people use them for writing, interestingly enough, and some for bookkeeping, but emailing was also very popular, and most of you will have parents, like my own, who will use it for Skyping with grandchildren. A lot of people also used it for travel and hobby and news, and so and most people used more than 3 applications. So this is interesting information. But what we found was that memory functions, the ability to learn this episodic memory, was highly predictive, was independently predictive, independent of education, of poverty, of access with internet use. So currently still, most of the sites require people to have memory. It's just how do you switch it on? So part of this might also be looking at the hardware and making it easier to navigate computers. And mobile phones have already done this. Is really interesting development, where they had a whole bunch of mobile phones made for Africa, which were very simple, which didn't use a lot of battery capacity because it's difficult to charge often when you're in the bush somewhere. So these are very simple phones with just buttons for ringing people. They have a simplified design, so it's not very complicated hardware. And what we found was that the older people actually much prefer to use these very simple phones rather than the ones, the smartphones where you're forever trying to just make a call and then you end up sending emails or going to YouTube and having some rock song played to you or something. So this is important. The other thing is that well-being, the level of depression, about 1 in 5 elderly has a clinical depression. And we were a little bit apprehensive in that we thought that maybe some of the older people would be too depressed to engage with ICT, but that didn't explain the variance at all. So in fact, it might even, there are studies suggesting it improves quality of life. So this is important. We need to have ICT training. In particular, one of the things that we're doing is we're using champions. So a lot of studies have found that if you're trying to engage elderly with computers, you don't want to have some 17-year-old going, at 100 miles an hour. So what we do is we are working with digital literate people and asking them to help other people. And that is definitely the preferred option in helping people navigate, take it easy, make a social event out of this, and so also promote some quality social interaction. And so in Brazil and in London and Hull, we're now doing this with Pride, where we're using these cognitive stimulation programs, and I hope to present about some of this maybe next year with my colleagues. And the sort of stuff we do is helping people browse, do some researching, play games, stimulate spatial processing by using online origami folding, using photography outdoors and then scanning that in to create a visual diary, using music on the computer, which is very popular, virtual tours and maps with Google Earth, using remote control devices, and we're actually getting a lot back from the older people themselves saying, oh, we found this and the other, and it seems like a lot of fun to do. So in sum, there's been a lot of research into lifestyles to treat and prevent dementia and its symptoms. There's a lot of contrasting results, but overall, I think if you look at the data, if you actually look at the actual data, you can see that certainly exercise a couple of times a week, it doesn't have to be every day, but 3 times a week, 20 to 30 minutes, already does a lot of good. You can do it on the couch. You don't, have a walk to the shops instead of taking your car. It's all that sort of stuff. It doesn't have to be going to the gym and hanging out with all the big muscled 20-year-olds, which is incredibly depressing. So you can also use cognitive stimulation, but not all cognitive stimulation works. So as Professor Fisher said, you want to be looking at personalized treatments. So you, for instance, playing Pokemon is going to make you really good at Pokemon, but it's not going to help you shopping, okay? So you need to, not all tests necessarily generalize. So a lot of these expensive brain games don't generalize to other activities of daily living. But there are some around, like cognitive stimulation therapy, perhaps learning therapy. Diet is a little bit iffy, whether that can still do something. I don't think it can hurt if you use it in moderation. But the effects seem to be mainly important prenatally, all across the lifespan, certainly up to midlife. For smoking, interesting enough, for those of you who still smoke, if you stop in midlife, the effects on dementia risk are almost nil. So you can stop now and then go on with a clean slate. So if you're trying to use website to transmit that information, you really want to make sure that you're taking into account these changes in information processing. But for that, we need to have all the people. And so that's the PPI most people talk about, the public and personal involvement, because these people are your champions. They will tell you what they need rather than you telling them what they need. And so you need to take a step down as a researcher if you haven't done that already, and have a slightly humbler approach, because these are the people who will be taking it up and who will be promoting it for you. So we work along these principles. Lifelong approach, as we said, and I'd like to acknowledge all these people again, including all my colleagues from Pride and the UCL, people I worked with in Cambridge. Professor Brain is fantastic, the funders, and of course you for listening. Do you have any quick questions? None. It was so crystal clear. Thank you so much. I'm sure you... Thank you, Shin. Thanks for listening.